Today I explain about the sun information. To watch the full video. The sun, the star at the heart of our solar system. The sun, the luminous sphere at the center of our solar system, plays a crucial role in sustaining life on Earth and governing the dynamics of the celestial bodies that orbit it. As a star, it is both a provider of light and heat, but its influence goes beyond just those visible to the naked eye. The sun is an immense powerhouse, radiating energy across vast distances, shaping the climate, seasons, and even the emergence and sustenance of life. This article delves into the nature of the sun, exploring its composition, structure, and its impact on Earth and the solar system. The composition of the sun. The sun is primarily composed of hydrogen, about 74%, and helium, about 24%, with trace amounts of heavier elements such as oxygen, carbon, neon, and iron. These elements exist in a plasma state due to the extreme temperatures within the sun. The process of nuclear fusion, which occurs at its core, is responsible for converting hydrogen into helium, releasing vast amounts of energy in the form of light and heat. This energy travels outward from the core, making its way through various layers of the sun before radiating into space and reaching Earth. Structure of the sun. The sun is made up of several distinct layers, each with unique properties. These layers, starting from the innermost region, are: Number 1. Core. The sun's core is where nuclear fusion occurs, and it is the hottest part of the sun, with temperatures reaching approximately 15 million degrees Celsius. This immense heat and pressure allow hydrogen atoms to fuse and form helium, releasing energy in the process. This energy is the source of the sun's light and heat, which eventually reaches Earth after traveling through the sun's other layers. Number 2. Radiative zone. Surrounding the core is the radiative zone, very well, where energy from the core slowly moves outward in the form of electromagnetic radiation of this. In this region, the temperature is slightly cooler than in the core, ranging from about 2 to 7 million degrees Celsius. The energy takes an incredibly long time, sometimes over 100,000 years, to pass through the radiative zone, as it is constantly absorbed and re-emitted by particles within the zone. Number 3. Convective zone. Above the radiative zone lies the convective zone, where energy is transported by convection currents. In this region, hot plasma rises toward the surface, cools, and then sinks back down to be heated again. This process creates the boiling or bubbling appearance that can sometimes be seen on the sun's surface. The temperature in this layer drops to about 2 million degrees Celsius near the top. Number 4. Photosphere. The photosphere is the visible surface of the sun, the layer that emits the light we see. It is much cooler than the inner layers, with temperatures around 5,500 degrees Celsius. Sunspots, which are cooler, darker regions caused by magnetic activity, are visible in the photosphere, though it is only a few hundred kilometers thick. The photosphere is where most of the sun's visible light and heat are radiated into space. Number 5. Chromosphere. Above the photosphere is the chromosphere, a thin layer of the sun's atmosphere. The temperature in the chromosphere increases with height, ranging from 4,000 to 25,000 degrees Celsius. It emits a reddish glow as a result of the hydrogen burning, but this glow is usually only visible during solar eclipses with specialized instruments. Number 6. Corona. The outermost layer of the sun is the corona, which extends millions of kilometers into space. Despite being far from the core, the corona is extremely hot, with temperatures reaching over 1 million degrees Celsius. Reason for this high temperature is still a subject of scientific research, though it is to be related to the sun's magnetic field. The corona is also the source of the solar wind, a stream of charged particles that flows outward through the solar system. The sun's energy output. The sun is a massive energy generator, producing about 3.8 x 10 watts of energy every second. To put that into perspective, this is enough energy to power the Earth for millions of years with just a single second's worth of the sun's energy output. The energy produced by the sun is released in the form of electromagnetic radiation, which includes visible light, ultraviolet UV light, infrared radiation heat, and other forms of energy such as X-rays and gamma rays. The energy from the sun reaches Earth in about 8 minutes and 20 seconds, traveling at the speed of light. This energy is essential for all life on Earth, driving photosynthesis in plants and maintaining the planet's temperature within a range that allows liquid water to exist. Subscribe our channel for learn many info.